So no wonder that you're not like in it from the get-go. GM, Hot Takes and Cold Wallets, episode number 24. We got a premiere here today, not only because Lewis is here as a guest, but we also got Umar here, CTO of Chain Patrol. GM, Umar, how are you doing?
I'm doing good, GM. Yeah, things are pretty nice morning today. And I'm glad to join the show for the first time. We've had a couple of other members of Chain Patrol join throughout the year. Juan, of course, has been a mainstay. But yeah, I'm happy to jump on, and I'm excited to chat today.
Juan, how are you doing? Early morning for you guys.
Yeah, doing well. Just kicking off the day. Excited for everything ahead. We are going to have like a few conferences happening in June, so pretty excited for that. For the whole team to be showing and seeing like different experiences of that. And on the Chain Patrol side of things, yeah, things going pretty good. Umar can of course share more details about like upcoming things that we are doing on the product side. Some things we can say, some things we can't say. But what we can say is that everything pretty much excites us a lot. We are like in a really good spot to keep on protecting a lot of companies, not only in Web3 but also outside of Web3 as well. So yeah, things going well. I'm pretty excited for everything ahead.
Also want to say herzlich willkommen to Lewis in Germany. GM Lewis, how are you doing?
Thanks for having me. Excited about this.
Yeah, we're going to talk about MEV protection and public mempools today a lot. So I'm not like an expert in the dev side of things for mempools and all of that stuff, but gladfully we got Luis here today. But we're going to start with the Chain Patrol update first. So Juan or Umar, whoever of you wants to go first, like have a little update on what happened since we last spoke.
Yeah, I will give to Umar so he can give an update first.
Yeah, I mean, honestly, nothing is like working in security, so there's always something new going on. I know a lot of people have been talking a lot about supply chain attacks, talking about sort of AI insecurity and stuff like that. From our end, for the last like 30 days or so, we've been really laser focused on improving sort of our detections and going out into new platforms, understanding, how's the threat landscape changing with more threat actors in the space leveraging AI. I think the biggest thing that we've seen is like really like we do brand and community protection, and the biggest thing that we're still seeing was a problem before, but it's been accelerated, is targeting of developers. And so we've been doing a lot of research internally about credential leaks, looking into how PI gets leaked, what information developers are kind of freely uploading on the internet, and that could be used to target them. And sort of a lot of that is like scraping GitHub, understanding what's going on NPM. And I think a lot of people are a bit worried. And so, and especially our customers have talked to us a bit about sort of where is my data going and how can I kind of keep track of everything. In terms of like what we've been shipping, it's really been our core brand protection engine. We've been really doubling down on like a rewrite, you could say, of parts of it, improving our operational efficiency and letting us leverage new data sources that we've been, getting access to. I've been collaborating more with the X team to better understand the threats on their side, leveraging XAI, Grok, all the tools that they have there to kind of analyze what's going on the X platform. And we're finding new patterns, new kind of ways to kind of search for things and get stuff taken down faster. and we're just trying to like continue and do that across Telegram and social media for the most part. That hasn't gone away. I think it's just been social media plus developers being targeted for the most part.
Yeah. Anything to add, Juan?
Well, I will say that we started seeing more attacks. I will say on the channel hacks on the crypto protocols. I think we had a hack on a protocol related to Monad that we can speak a little bit about. Then I also saw like a lot of compromise on like GitHub that was like people panicking a few days ago. So that was quite interesting thing. Umar can of course share more details about like what are the actual implications of a GitHub compromise and what's might be the extent of that. So I think last week we have said like it was great to see not big hacks happening in crypto protocol for the first time in probably like the last 2 months, but we are starting seeing different kind of attacks right now that can affect much more things that not only Web3 companies and DeFi protocols in general. So yeah, landscape is getting more complex. And as we speak on all the different sessions, scammers, threat actors are using AI tools. The only way to combat them is to also use AI tools in a smart way, and also in an efficient way to try to combat them and get them to remove and stop like the attacks that they are doing. So yeah, things going really well and interesting, I would say.
Doesn't always have to be a hack to get a legitimate user in trouble or get them like money stolen, and this is why we got Lewis here today. We're going to be talking about encrypting the mempools and the movement of encrypting the mempools. So Lewis, welcome to Hot Takes and Cold Wallets again. Before we get into like the technical details and all of the nitty gritty, I'd love to like set the stage for this. And what was important from you guys was to tell that this is not only a Shotter story, but it's more like a movement. You said it's going to be like a broader movement, like supporting your effort to come to the conclusion that encrypting the mempool is like a good thing, and we need devs, builders, flashbots, the community basically to rally behind that. Can you share a bit about that?
Yeah. So awesome. Thank you, Shu, for having me. I'm Luis with Brainbot and Shatter. And Shatter is this kind of threshold encryption as a service mechanism. So it's just the encryption decryption part, and it provides this encryption decryption to mainly this idea of the encrypted mempool. We also have we also have other use cases, and the primary one is voting. So it's also implemented for voting in Snapshot, and where it protects the real-time results, but also soon long-term privacy via threshold homomorphic encryption. Yeah, but that's just a note on that. And then I like your question. Yeah, like what's the movement or why? Yeah, so I think originally we started out with this. It was just us, and maybe Martin from Gnosis had very similar ideas, and we collaborated with him back then to release this idea of an in-protocol encrypted mempool. So that was pretty much Shatter and him basically. But now it's really like this multi-pronged thing where we have our EIP proposal to implement it, and we have the Lucid team, which is kind of an Ethereum. Two members from the EF and one Justin is from Besu, the client, who have their own EIP for an encrypted mempool, quite similar, and we're collaborating with them. We're together that movement, I would say, and also other kind of PBS transaction supply chain projects such as PrimeEv and builders. BTCS was very supportive in the past, and now is Quasar Builder as well. So builders are interested in this, and wallets. And then also we're seeing other chains now do this as well. So in the past, we've seen Anoma work on this. I'm not sure how. I think they're live by now. I think they're focusing a little more on payment. But yeah, I think the DKG and the encrypted mempool is still part of their thesis and their design. And just recently, Aptos presented their own take on encrypted mempool using also threshold encryption. So quite similar to what we're proposing. But I would say Ethereum ecosystem should still be ahead. We have the prototype on Gnosis chain or POC basically, and we have this PrimeEv integration. So I think Ethereum is still on top and the fastest in adopting it. But we see it's not an Ethereum thing; it is multiple people. Yeah. Just side note, Arbitrum as well. Arbitrum plus Espresso are building this time boost, which is also an MEV kind of payment, kind of like market thing. But the version decentralized time boost, what they call it, decentralized time boost together with Espresso, is also I would call it also a form of encrypted mempool, because they again use the decentralized time boost means they have the decentralized sequencers also running a DKG and decentralized encryption. So that's also another thing.
I want to take a step back on this and ask how it came to be basically your passion to be like rooting for these encrypted mempool. What made you decide that this is the one thing you wanted to follow and wanted to pursue in Web3 or in DeFi or crypto, whatever you want to call it?
Interesting. Yeah. So not necessarily my personal passion. Maybe, well, not sure. Yeah. So I'm more financially minded and maybe even more interested in the in also the other side, the arbitrage and like the trading side, from like passion wise. So it's more really our project Shutter and Brainbot. It came out of our scalability research back then, and basically we noticed that this type of threshold encryption and this kind of decentralized commit reveal system could not just be useful in a scalability context, but could then deal with this emerging issue of MEV that there was like emerging. Flashbots kind of brought this up, right? And then at the time we was like, okay, that is kind of the solution. Or that is sort of the one that that could be solving it there. So that's kind of just fell into that a little bit. And only later did we discover, oh, this is a big problem. And then even later, I think we connected it to the bigger picture of not just MEV, but kind of this whole, I would say, base layer neutrality and censorship resistance. Because like MEV is sort of like just a kind of a one of the symptoms a little bit. Whereas the bigger picture is the neutrality of the sequencer and them being able to reorder or pick transactions out or censor basically. And that's where I think it connects to this bigger picture of, if you can't see what you are sequencing, or if you can't see what you're putting in the block, that helps a lot with censorship resistance as well. And then so that's how it.
We're going to be phrasing this a bit more for the less technical listeners today. So we're going to be into the 101 a bit more about MEV and how this actually happens. Umar, did you ever have the feeling that the current mempool model that we are running with crypto isn't good enough?
Yeah, I mean, it's not really a question of good enough per se. It's more of a question of, it's like, for me, like the crypto space was kind of like a sandbox to experiment with ideas, right? Like traditional like order flow, like market making and all that stuff is like very heavily centralized, right? Like you look at a company like Robinhood and payment for order flow that they have, you submit your trades to them and then they sell the order flow data to like Citadel and other big trading desks that can basically do MEV for themselves, but just on like a more private gated access kind of situation. So for crypto, it's like it just makes that information more publicly available. And I think in the beginning of the kind of mempool wars, like we really saw the different end of the extreme of that, which is just like, what if we have it's like completely neutral, right? Like, can we just let everyone just arbitrage on these opportunities? But then you get really bad user experience. You get like a lot of transactions that never get finalized. You get a lot of sandwich attacks. I was just seeing like a couple of weeks ago, like there was that transaction from Vitalik where like Jared from Subway sandwich attacked him. I think it was like just some like altcoins that Vitalik was trying to transfer out, but like it just gives kind of points to the kind of challenge there at the network L1 level in Ethereum. There's no real protection against it if you want to be protected. And right now the alternative is like go to an L2, mostly centralized sequencers, and like use tools like Flashbots and other MEV like kind of front running protections. But you lose that decentralization. So I feel like in crypto, you can test both ends of this extreme. And what we're hoping to find is that there are options for people who want protected, non-visible transactions. Because as long as you can see, you have private information that other people don't, there's that ability to make these, kind of arbitrage opportunities. So I don't know. I think there's still a lot more to explore in this space, but I think encrypted mempools where the actual people who are ordering the transactions maybe can't see the details is something that I'm interested to learn more about, and sort of what is the cutting edge there. I may have also made a couple of assumptions, so I'd love for Lewis to correct me if there's anything that I'm making any wrong assumptions about.
Lewis, I want to
great.
take a step back, if that's okay, for a second, for the less.
Just one note. I think it was great. Just one note. I think it was never neutral in the first place, right? So like even in the original status token ICO, you could see this weird pattern where one miner, like people who went in and bought via one of the transactions got sequenced by one of the miners, they had an extreme latency advantage to the others. So like even back then, people were paying the miners back then, like before the merge, right? For sort of priority access to the mempool. So I think the larger point is like neutrality on this timescale, on this shorter timescale level, was never actually achieved. And I would say like private mempools sort of band-aid the problem, where like you trust someone basically. You always have to trust someone or a group of people to not front run you. So they band-aid this problem. But like as you said, it's not really solved on this decentralized and this true level. Sorry, I don't want to add that, but otherwise I think very good.
It's all good. I love that we have like the conversation flowing. I'm just taking a step back for the listener who's might not be that educated enough to even think about the mempool, because from the talks I had with people, they might not even think that, hey, if you sign a transaction and your transaction gets broadcasted to the network, then it usually sits a while in the mempool before it gets executed. Can you explain in plain English, Lewis, for the listeners that aren't aware what the mempool actually is and what it's supposed to do?
Yeah, I think that's what you said. Yeah, so it's this waiting area for transactions that float around, and the public mempool is public. That's just like imagine some peer-to-peer gossip network where nodes send these transactions back and forth until a validator, traditionally, like before PBS, before separating these roles, you just have a validator who gets the kind of the role of building the next block. They look at this public mempool and they see, okay, well, what's in there is that how much fees are they paying me? So if they pay a high enough fee, then I just put them in a block and I boom execute that. And as you said, like then there is a centralized gatekeeper there. Basically, there's per block there's one. Like back in the day, it was the miner, then the validator. Now it's the proposer/builder, and they can see what's there, and they can essentially front run, right? Ultimately, they can front run because they have the power to order and to include and reorder transactions. So if they see something that's interesting, for example, a transaction moving the price, let's say up a lot, right? That would move it up a lot. They can say, okay, that's interesting. Let me jump between. Let me buy from the currently still cheap price on Uniswap or on the open exchange, and let me then this other transaction that's already signed, is already needs to come through, is committed, can't be pulled back, or at least not in this time frame. You can then buy cheap from the public market, drive up the price basically for this guy who wanted to buy, sell to them. So it's like front run and then the back run kind of sort of sandwich. That's a sandwich basically. And then then this guy who wanted to make this big trade, they just got a really worse price because someone drove up the price right before a transaction. But, I think that's kind of the core issue, I would say.
Juan, do you think that people understand this? That if they broadcast a transaction, actually someone can basically quote unquote jump in between and drive up the price and make it more expensive for them to buy tokens?
I mean, definitely, if you are into crypto, you probably have heard some news about this happening. I think Mara mentioned like Sharad. I think that guy is like pretty famous in Twitter. Like, you know that these are things that can happen, and that guy is pretty much doing millions on doing these kind of sandwiches over the last couple of years. But I would say, from a user perspective, let's say you're a user that like used to invest like in finance, invest in like, or put only your money like on centralized exchanges that might have like some kind of solution to avoid this, is I would say it might be a surprise. I mean, if you want to do like a big transaction on chain, you might not be thinking about like the possibility of a sandwich if you have never heard about, if you only have been, again, doing transactions on finance or a central exchange that might have more protection to these. And you are like just a regular user to try to do these things for the first time, you might have like a big surprise so that actually get much more tokens of what you are supposed to do. One thing I would say is that, yeah, as a regular user, what you usually might be seeing is like the cost of the transaction. You even know that you need to pay a gas normally in the native token of that blockchain you're trying to transact, but you don't think about the possibility of a sandwich attack, I would say. So definitely it's two things, I would say. Number one, we need more education about this, that this can happen, because I think whenever we are discussing about doing transactions on a decentralized state, we don't talk much about like the possibility of having like a sandwich attack and when this might actually happen. So I think we have like a one requirement for education. And number two, these actually, well, we were discussing about last week with me about like UI issues. These maybe also qualify like say a UI issue for general crypto stuff. I really like what Omar mentioned about like crypto being like a sandbox, a place where people can experiment and do different things. Maybe this is something that we need to fix in the next stage of like, next stage of like decentralized blockchains that we're building. And I think Shara is doing like a good job in trying to implement this as something that needs to happen to all different blockchains are like in place, active right now, and in the future as well.
We're gonna be coming to the proposed solution from Shudder in a second. Luis, I just want to ask you, like personally, from your experience, do people even realize that they were sandwiched, as like the first question? And additionally, then, how important is it that we do the proper education for the whole like active crypto community, like the active users around this, to be rallying behind the proposals that you guys are doing?
Yeah, I think most people don't realize the full extent. I think but I think there's different groups that are differently educated, basically. So I think there might be still some people, really normal people who just kind of come into Ethereum and they do their first Uniswap trade. They might be fully oblivious, right? And they just use the default, and they are probably the cleanest victims, right? They will literally get front run. Even Vitalik.
We had this 99% slippage trade on Aave like a few weeks ago, right?
Which was was informed. I think there was, but there was more informed. There was someone using CowSwap, so I think CowSwap is already, but that's a more complex issue, I would say. But I would say like just someone literally Uniswap, right? And Vitalik, I think, did that, right? I think as we understand it, he just used the public mempool, get front run, boom. So those people, Vitalik knows it, but like someone else coming to Ethereum like this actually doesn't know it. Although I would probably say like that's not the majority of trades, right? Those are really the new folks on that really don't know anything. So probably the most trades and most frequent traders, they know about this. Because the professionals to a certain degree, or hobby professionals, so they're probably use Flashbots or let's say something like CowSwap. Although then I think the level of understanding I think also is like is not the full extent, because they just think, oh, now it's fixed. I just switch on Flashbots and the problem is fixed. Whereas I think that's not fully true, because I think that's a huge trust assumption to just trust this private mempool operator. And also and twofold. So they need to trust that it's not being front run, and sometimes it gets front run. So we saw this also with MEV blocker, that someone just leaked it, and then someone along the chain didn't keep its promise, and they said, "Oh, this is a too big profit. I do want to front run this." So the trust assumption only reaches so far, right? And someone will leak it. And number two, it compromises the whole idea of like, let's have a decentralized blockchain and have like no trust assumptions, or at least distributed trust assumptions. And so they might think it's fine, and they might actually be fine on the short run. But I feel like the whole idea of Ethereum is a little bit compromised, and they're no longer truly trading on a decentralized ledger. They're trading against and we're seeing this thing emerges, right? And we're seeing it go into this more TradFi way, where you just trade maybe against a market maker or broker, and as Umar said, like this payment for order flow thing, and that's kind of moves away from the original vision. Yeah.
Umar,
So I think different levels of
Umar, what do you think? Like, how much of this could be solved on an app layer compared to like the protocol layer itself?
Yeah, I mean, apps are trying to solve this because at the end of the day, it's a user experience issue. When someone is interacting with like a Uniswap front end, or swap in their provider in their wallet, like they're not really thinking so much about what network level protections there are. They're really thinking about, hey, I'm connecting my like wallet to here. They're the ones who are like essentially responsible, and it's like either my transaction is not finalizing, or like I got much less than I expected. And they think, yo, did Uniswap steal my money, or did like like that's kind of like the question that they might have. It's like a lot of people aren't thinking that deeply about whether the network level protections there. I do think it's like certainly worthy of an EIP though, because it's not like you can't solve it at one level. It requires protocol level integration, I think, because anywhere that you have like ability to look at the private information and make a decision before that the other person, the other person who's submitting the transaction, like you're always going to have that opportunity, the MEV opportunity, that ability to arbitrage on the trades, find a better, if it's like a pool that has like you can check the price and the amount of liquidity in it. You can kind of deterministically predict what you making a trade before that can do. There may be some limitations that people have like even tried to trick bots and stuff like that, but it is kind of like inherent in design. I think wallets and dApps could do a better job of maybe like Lewis was saying, like the high frequency traders, like the more experienced traders already know that this is a problem that they have to like work around. And if they are going to ever trade large amounts, they need to be careful about how much information they disclose about who's making the trades and by how much. So maybe it's like figuring out like for the early traders, or maybe like small, like if someone's trading a large amount, like really making it clear like the risk essentially. But people are going to trade. You can't really stop that. So I think it's just, you have to, at a certain point, either you have this censorship at the app level, or you have censorship at the protocol level, or both. And I think with I'm interested in things that like solutions that maybe like don't necessarily try to stop MEV per se, but make it sort of more equitable in some regard. Those seem like the more direct path, but obviously if someone can present me with a solution that's like better than that, I would love to hear it.
Yeah, just to add to that, I think the one simple way, the app level versus protocol level, is I think you can solve it on the app. I think CowSwap does solve it to a certain degree, although not waterproof, as we seen I think just a month ago. Yeah, was a 30 million trade or exploit. But then it's really just for that app, or for this specific batch auction exchange design, and then it doesn't work for all the interesting kind of DeFi money Lego things that happen between DEXs or between DeFi protocols. And that's the whole point a little bit, right, of Ethereum. And it fragments. So the more, if you solve it here, then it fragments everything within there. Yeah, so fully agree with
you lose that kind of composability of of the network. Yeah.
I just wanted to highlight here that basically it's you as the human trying to get into a race with bots, by the way, if that wasn't clear till now. Like, you're competing against bots with the front running and all that. Like, there's no way like a human, like a normal user like you and me would win these kind of battles against the bots that are trying to, yeah, max extract, as MEV stands for, maximal extractable value. Okay, so Luis, you guys over there are proposing an encrypted mempool as the solution, basically, and this is a bit more technical, and we have seen like difficult or different approaches to this. We have seen like different EIPs, as you said. You have seen the Lucid proposal that they made. There are private mempools. You guys are rooting for encrypted mempools. Can you take the user along with you and explain how encrypted mempools are better than, let's say, private mempools?
Okay, yeah, maybe let's really start from this, like, first, maybe kind of private and encrypted compared to public, and then maybe let me differentiate
Yep.
private versus decrypted, and maybe we can use this MEV simulator that we built to showcase this. Yeah, but high level, basically the public means everyone can see it, everyone can front run me, and then I get front run. Private / encrypted means nobody else ideally sees it, and that way they can't front run it, roughly speaking. So yeah, because if the kind of the block producer can't see what's in the transactions, very hard to front run. So ideally we need a way to sort of like hide the transaction contents during the block building process, and then we can actually, if they have committed to the order and committed to the inclusion, they then we can actually decrypt and execute. So then we can use the fully normal like execution protocol pipeline of the protocol. So that's kind of the high level idea of like the encrypting the transactions. Encrypt them. Block producer needs to commit to the ordering and inclusion of transactions while blind. Kind of like think like envelope, right? And you put the transactions in, and you give the sealed envelope to the sequencer or the guy who orders transaction, right? And they need to sign and stamp the envelope while it's still sealed, right? And then there's the whole sign, and then only afterwards can he open, and then yeah. So that's basically the high level. And then maybe we could just jump into this like little MEV simulator to show what the impact of this is, just on a very simple model. Does that work? If I Chrome tab this, there's something we recently built. Is like we saw that there is this need for just like making it apparent or building a simulator that can be ideally an open source, open module kind of framework where anyone can simulate their ordering strategies or their different scenarios, and then see economically what happens, right? So, and here our basic scenario is Uniswap v2 sandwich. This is our first scenario, very simple. You can now change this config yourself. I think one really nice way is just clone the repo, tell your coding agent to modify the config in a way that conforms to what you want to ask about it, right? But let's say you just use the default, load that in, and now it's loading up the scenario into the thing, and it spins up an Anvil chain to simulate this very simple people trade, basically two different groups trading against an Uniswap v2. One is it's like three actors. One is the guy who just publicly trades against the public mempool. Two is the guy who trades against the private / encrypted mempool. And number three would be the front runner who just front runs everything he can see, right? So just very simple. And then we just see, we can like fast forward the chain. So it's like it's a full chain simulation, but it's just like fast forwarded, right? And you can kind of like see the price of the AMM developing, just random walk, right? And you could see the actor's net worth. And we have the green is the private trader and blue is the public trader. And you just see like, okay, it diverges, right? Over time, the more they trade, each time they lose a little bit in terms of like getting front run. That's kind of the very simple high level explanation. And you pause, right, and you could see, you could jump into the transactions. Yeah, and you can ask it questions, right? I think that's a cool idea. Like you could just like download it, clone it, and coding agent ask it to run it, let the full thing run, and just give you a report on your research question. Yeah. So I think that's kind of like the difference between public and private / encrypted. And now I think what the topic was more so was between private and encrypted mempool. So private now is just like you trust some guy or even multiple people to hide you send it to this private mempool, and they have some access to a builder or some access to the blockchain, and they make sure that nobody else sees it. And hopefully, just at the end, the builder or proposer, and yeah, and just this relatively simple way of you kind of circumvent the public mempool, just send it more directly to the builder. But you need to trust them, basically, as you need to trust multiple people, at least kind of the RPC provider for the private mempool and the builder as well. And they use TEEs, right, and something like this. But like ultimately, you need to, or some of them use TEEs, but ultimately you need to trust. Encrypted mempool says we need that sort of encryption decryption at the protocol level. We need it to be, as I said before, we need it to be the order and inclusion be finalized while they're still encrypted, and only then do we decrypt and execute, and then you achieve hopefully just a level playing field. And the cool thing is, like, on terms of like background, it doesn't prevent all MEV. It can only, because of the way it's structured, or just because of the nature of things, it can only prevent front running, and it can't really prevent back running, nor would you want that, right? So MEV, you have front running, back running. Front running is before, back running is right after your transaction, right? And usually what people say is back running is okay because it means it's like an arbitrage, or could be liquidation that is actually good for the market and that actually levels the prices across exchanges. And that is sort of unaffected, largely speaking, with this design. So it just prevents the front running, and then the back running, we can just deal with it like you would deal today. And even like what some private mempools are doing is pay back from the MEV proceeds, pay back to the user, pay some of it back to the user, right? That's something that's totally possible also in that design. Just eliminates the front running, and front running is going away anyway. So like people are, even like Flashbots and other all private mempools, everything would agree like it doesn't make sense to like bank on front running as your income source.
Yeah, like for the normal user, I just try to think of a real life scenario where you can like apply the concept, because it's a bit more technical.
Rock, paper, scissors.
Yeah, but if you think about like votes, well, votes would be a very, very good like example. I think if everyone was able to see the votes like from the individual people before they get like broadcasted as a result, it's kind of basically like the same. You see, hey, Umar voted this, Juan voted that, Vimy is voting this. Even if the final result is not in, everyone could see like, hey, Umar is going to try to vote this direction and Juan is going to try to vote this direction. And this is what you said with the envelope, Luis, basically, that the envelope still remains sealed until the transaction has been executed. I think this is like a good analogy. Is that right, or is it missing something?
Yeah, very good. Yeah, and as I said, we are also applying this to voting. Yeah, maybe another simple one is rock, paper, scissors. Right? Think about rock, paper, scissors. Two people playing, and if they don't reveal at the same time, the game is like broken. If you show your hand to the other party beforehand, and the other party just reacts to that and say, okay, good, rock, I do paper, boom, lost. So you need to make sure in these games, and in an exchange scenario as well, you need to kind of make sure that they have the same, that people are revealing at the same time, essentially. Yeah, and that's what Umar pointing to in the real world. The same problem happened in the real world. You just have an exchange which makes sure that you have the same level and you have regulation enforcing it. And we don't have that luxury sort of in crypto.
Yeah, it's important to kind of recognize that like in traditional finance, like they have, it's basically like illegal to front run like transactions. Like in most markets, like exchanges, like if you caught doing that, which is people have been caught as recently as maybe like 2020 or something like that. Like it happens all semi recently. Recently, you get fined or your license could be taken away, right? So like you're in a decentralized world, we need to find a way to kind of keep this social good, I guess you could say, because otherwise people won't trust to even submit transactions if they know that bad actors are just gonna almost guaranteed front run, especially with automated trading. In the traditional finance space, my understanding is that like this happens a lot with people's ability to get closer or reduce the latency between them and the market, like to get the information that they need to like make front running trades. And it's
insider trading also, right?
That too. That's almost like related, but there's also like a bigger problem there. But the exchanges have kind of tried to solve this by adding artificial latency to, like, they literally create coils of fiber optic cable in some of the internet exchanges in some of the stock exchanges to like artificially balance out the latency differences between different data sources. And I think in crypto, that's not really possible in some regard. It's like you can only do that if you have full control of all information, but like anyone can run a node, anyone can, as long as they stake their ETH and maintain a good reputation, they can continue to provide services to the network. So I think there's certainly some differences, but I think the rock paper scissors example gives like a very simple kind of understanding of what can go wrong. And if you play that out over a long enough period of time, you realize that it attracts other people as well. Like you can automate that. Humans are always going to be slower than a bot to find this, and so people will just keep finding the mechanical advantage. Find faster chips, go closer to the data center, bribe someone, with gas or whatever it might be.
So Lewis, to make your suggestion come to life, how would we go about it? We already talked about EIPs, Ethereum Improvement Proposals, and you guys, correct me if I'm wrong, but you guys had an EIP running, and then basically you decided to go with the Lucid proposal. Is that correct?
Yeah, for this vote, it's more complex. So I think we have our EIP, Lucid team has their EIP, and then there was a vote for inclusion for the Glamsterdam hard fork, and we said we don't want to split the vote between these two quite similar proposals, so we threw our weight behind the Lucid proposal. Although I think both EIPs aren't really there yet, so there is some good feedback came off of this process, and I think we need to create a new one, I would say, because there's some basically right now the encrypted mempool as it stands right now, I think will already be lengths better for the users than the public mempool, because they just don't get front run, right? They just get better performance. But I think there is still some structural sort of disadvantages over the private mempool, because the private mempool people have this advantage, for example, of you can do more with the transactions. So if you trust the broker basically, or the MEV, the solver, right, they can then pay you back more from being able to meddle with the transactions. And that kind of efficiency gain there, or that basically this like ability to generate value from your transaction, and as I said before, like that should be the same, because you don't want to get front run anyway. You do want to get back run. So like we just need, I think the next iteration of the encrypted mempool EIP would have this fully built in, that you can get the same or very similar level of efficiency and kind of refund than the private mempool. So yeah, so that's how I see it. And basically, yeah, it needs to be on the protocol level. We have these two EIPs. So what I want to add is that it is on the EF Strawman roadmap for schedule. There is an encrypted mempool scheduled for iStar hard fork 2027. So essentially, EF are a little bit hinting at it does make sense to include it. Yeah, just like the exact design, I think we still need to work a little bit on or improve it.
Yeah, I mean, Vitalik was also talking about like privacy and censorship resistance and all that, so that fits the category pretty well. I was gonna ask, like, Luis, like, if it was like that obvious no-brainer that everyone was like, yeah, like, of course we need an encrypted mempool, it would probably be integrated by now, but there are trade-offs. Can you like tell me or tell the listener to what were the most common trade-offs that people were arguing against when they maybe like had a discussion with you about this topic?
Yeah, it's funny. It's like I think people would say like it is obvious that we need an encrypted mempool. So, but yeah, there's trade-off or there's like complexity involved. I think is the main one. It is basically, yeah, it changes a little bit the state transition function, essentially, roughly speaking. But the cool thing there is other proposed EIPs in the works where we need to go in that direction anyway. ePBS was such a thing as well. ePBS meshes very naturally with the encrypted mempool, so that's what helps already. Yeah. So I think implementation complexity is maybe the big one. And then, as I said before, then it's basically just going to be better than the public mempool. And to me, that's already like a huge improvement, because then at least we can make the argument that maybe the public mempool can come back. Right now, the public mempool is just broken, right? You should not use it because you just get front run. So like at least making it 10 times better than the public mempool, or it is the public mempool, but as a public encrypted mempool, just making the public mempool 10 times better to me is already a huge win. So I would say then we should do it, right? And then I would say then the next trade-off becomes like there might still be these more trusted routes that are more trading efficient, where you get more money back or something like this, or depending on what you do or luck or whatever, you might get more money back versus the encrypted mempool. And I think that's where you need to work on kind of bringing the best of both worlds, basically bringing the ability to order transactions sort of like post-inclusion to some degree and extract value from the transactions post-inclusion, while still having these rules and having the inclusion be fixed before. I think that's the major thing as a trade-off. I think another trade-off is trade-off, simple speaking, right now you might not get the best price if you compare versus private mempool. Yeah. And the other trade-off maybe just like latency as well. So the encryption, decryption itself is not the issue, because that's shorter than the Ethereum block essentially. So that's not really the issue. But I would say like in the current designs, at least Lucid and ours, it would be like the earliest you can get a transaction in would be the next block. So like at least one block kind of like latency. Although PrimeF, they have this new proposal where they would say like, can we get same slot decryption? Might be a venue as well to cut down that latency as well. But maybe that's, yeah.
When you talk about latency and like, you're talking about the amount of time it takes to mine a single block, how much like time you have to perform that sort of encryption of the like close that envelope, sign and seal it, and send it to the block builder, or what exactly do you mean by that?
It just meant like the user experience of trade. When does my transaction get confirmed?
Okay.
And right now you would be able to do that to get like near instant, nearly that in the current block, right? If you pay enough. So whereas like the encrypted mempool, the process of the way how we build it is basically the decryption takes a little bit of encryption is very fast. You do that locally, right? Decryption would take a couple of 100 milliseconds. So that's a latency that is just there. So that and then just the way how we structure it, that it needs to currently go top of block of the next block, essentially. End of the block, depending on Lucid or whatever. You can do like top of the block, next block, or end of the block. It doesn't matter that much, but there's like inherent like one block. Basically, it's later than, yeah. Again, meta doesn't really matter for Ethereum, because like you're used to waiting a couple of seconds at least. Yeah. Matters maybe more for deploying it on an L2 like Mega ETH or something, where it's like yeah. So I'd say like implementation complexity, then 2 is like this: is it 100% competitive with the latest and greatest in terms of private mempool, in terms of getting money back or getting sort of like the overall price? Depends. I think it's not 100% clear cut there. And then 3, this like latency topic where I think matters to a certain degree more and less. Yeah.
Is there anything changed from the smart contract developer or DeFi operator perspective?
Usually not, right? Usually it would just act. It could just function like a normal transaction. Yeah. So I guess, yeah, the impact is on the wallets. They should have the way to encrypt. So they should have this cryptography SDK in the wallet application that encrypts, so that the user can actually encrypt. Although we also have this like RPC, so then you could just switch out your RPC and then you can send it more directly, but then you have that trust assumption, then the RPC becomes, so that's not ideal. Yeah. Ideally, wallets need to adopt. And then I think block explorers or like the real-time, like a little bit of an issue with like real-time, what's happening real-time right now to your transaction. It could be like a little bit different, because while it is still in flight, you can't see what's happening, right? And like transaction simulation and some things like this are going to be affected. But it shouldn't matter for normal people, because like you could still simulate yourself, right? You could just use a like Tenderly simulate yourself in plain text, and you can and also after it gets decrypted. So like the block explorer longer term also doesn't care, because it's just going to be as transparent as before in the block explorer. That's not. Yeah, but some like while it's happening, there might be some UX changes.
Yeah, makes sense. Like being able to like show you like, oh, what like a status updates of what's going on that might need to change how that information is retrieved.
Yeah.
Versus just probing a node for like, hey, give me the status of the mempool.
Yeah. Another way to think about it, like some things, intent-based systems and like private mempools, they have some features that the public mempool can't do. Like they can do some nice things where, like, for example, if you send a transaction to Flashbots, I think they can already tell you that it won't execute or something, and then you can save the gas costs, stuff like this. Like, because they have this full power and full simulation capability and full, like, that they can do some advanced stuff that the public mempool can't do. The public encrypted mempool probably also won't be able to do as well as the private mempool. So, but these are again things that private mempools have added on top over time. For us, it's more about like, first let's get the public mempool better than it is today. And yes, there are some things where it's not superior to private mempool. I think that's definitely true.
Great. I wanted to talk about, like, this is not just a theory, Luis. You guys have like experience with testing this in an environment like Gnosis Chain. And I was just gonna ask, like, how were your results and how have your ideas been proven so far?
Yeah, on Gnosis Chain was the first one, so where we deployed it in this more out of protocol fashion, and it was definitely an interesting journey. I think we should do an update on this soon, because as with a lot of things in crypto, it is more complex than you think originally, especially because here it's like multiple decentralized actors need to communicate with each other. So just like peer-to-peer communication was sort of a longer blocker, but now it's like figured out. And Aragon, so you can Nethermind and Aragon clients have this built in that they can receive encrypted transactions from the separate transaction path kind of, and they can process them. So Shutter and Gnosis, I would say, is the first one. And now we are about to launch with PrimeF. PrimeF is this out of protocol kind of builder and proposer commitment scheme called MEV commit. And there we have Shutter, sort of, or the crypto mempool acts as this kind of like provider to that system. So it's uses the Shutter encryption to be part of this, and would be to some degree kind of the first encrypted mempool on Ethereum L1, but kind of like with a caveat, I would say, because it's not it's not 100% safe, because like to be safe, it needs to be sort of in the protocol, and it needs to decrypt as late as possible. So encrypt as early as possible, decrypt as late as possible, and it needs to be kind of in the protocol. And that is then the idea of the EIP. And I think Aragon has already committed to let's try to build this even before it becomes fully like in the protocol. Let's build a implementation. So I think that will be the next step. So Gnosis, PrimeF out of protocol, and then maybe with Aragon a prototype of this in protocol one, and then the full one, hopefully once Ethereum.
Before we briefly touch on the future, because we had more topics, but we're gonna be covering all of them because we're already at the hour already. So I'm gonna send off Juan from the stage because he has to leave and get into the next call. Juan, thank you for your time.
Awesome. Thanks, guys.
Thank you.
Great as always to be with you, and great also, Luis, to have you here as a guest of the show. So yeah, we'll see you in the next one. Thank you.
See you next time.
Thanks so
Juan.
much.
So Luis, I just want to touch on the future, like very briefly, because this is just basically like the last thing we can speak for a few minutes. Do you think, or do you expect the encrypted mempools to be the default going down like the timeline of the next, I don't know, 2, 3, 4, 5 years maybe?
Yeah, definitely. Long term, definitely, because that's just makes sense. So this vision of blind ordering and blind doing everything, and essentially think about it like this black box of a trading machine that you put stuff into, and there might be even trading bots on the machine, but the rules are sort of like more transparent, and there is fairness and a level playing field for everyone who enters their transactions into it. I think that's no matter who you ask. Like if you ask Flashbots, for example, they would say the same thing. They would just take a different path there. So to me, like this, like encrypted ordering, and in general, kind of maybe L1 privacy in that regard. Also, then might as well just like keep it private for longer term. Like that's a secondary topic. So definitely, I think that's going to happen. So I think more the question is like the way there, and how quickly can we get it into the protocol, and how decentralized and open is that going to be? Like kind of the competition is that you just operate the builder in a TEE, and then you have this kind of hardware level of encryption, right, or like privacy, but you need to trust like that builder still to a certain degree, and you need to trust the hardware manufacturer, AMD or Intel, to not have like a backdoor. So that's kind of like maybe like the
Or bugs.
different path there. Yeah, I would say it's still like an encrypted mempool then. Yeah, it still makes sense. And so our design is encryption technology agnostic, Lucid as well. So in our view, that's complementary and can just be, you could just have the encrypted mempool and have one of the encryption technologies be TEE and one other special encryption, one other, I don't know what you want to do. So that's, I think, the interesting part, like how quickly and which path and how decentralized.
Yeah, Umar, what kind of excites you about this from a technical perspective?
Well, I think it's like we were saying, like to me, it seems kind of obvious that we would end up in this spot. Like I think like I look a lot to like other industries and like prior human knowledge, I guess. I've seen this kind of play out in like the scientific field with like double-blind experiments and like voting as well. People have proposed improvements to like voting, but it's always been more of like a social coordination problem than it has been purely technical. Like there is the technical aspect of it, of course, but that's challenging. But it's also just about like social, like people that, you know, like getting everyone to coordinate to get this all updated. So I think it would be a good sign to see like that adopted, especially with Ethereum, like you mentioned, like focusing a bit more as one of their stated goals around privacy. And I think also just like I would like to see, I'm excited mostly about like what the implications are from the end user's perspective. I'm also interested to see like what impacts it has to transaction simulation, because I know that's a big piece of a lot of the security features that are in wallets and third-party security providers are doing like tentatively simulations or their own kind of simulations to see if a transaction might be like malicious or negative for the end user. So I'm kind of curious to see like if there would be any like gotchas in that regard. It sounds like no, but there's always, once we get things in people's hands, they'll find ways to like extend it in user space to find ways to like make it better, or they might find other flaws, and then we'll have new proposals to improve those. Honestly, I would love to just have this live as soon as possible. I think it's just like one of those kind of like not rug pulls. I hate to use that word, but like it's kind of like one of those things that like gotchas that you have as the end user, where like, oh, if you're not using the private mempools even right now, like you could just suffer from a sandwich attack from front running. And I don't think we should just leave like a loaded gun like lying for most people. We should give people sharp knives, but I think you really need to give them that. If we can solve it at the protocol level, then like I think that's really valuable to me. At the end of the day, I think people are just gonna keep focusing on also just like new use cases to kind of build on top of DeFi, and I don't want this to be like a blocker for people to experiment with putting more interesting use cases on chain.
Yeah, my last question for the show basically is, when we look back at this episode in maybe, let's say, 2030, 4 years from now, will we find it absurd and ridiculous that we ever signed transaction into a public mempool, Luis?
No, because the public mempool will be encrypted, right? So that's how I see it. Is like we need to have the public mempool. That's that's part of the censorship resistance and the decentralization. Yeah. So, but yeah, maybe hopefully we find it absurd that people needed to be afraid. So I think that the core thing that we started with was like, now people basically need to be afraid to reveal information to the chain, right? If you have some idea, some trade, you reveal it to the chain, you can't do so safely, and somebody else benefits from every trade is information, right? Every trade is something that the others hopefully don't. And right now they need to be afraid that either someone like publicly can see that before and benefit from it, or a centralized actor. Yeah. So hopefully we look back and say that's not. Yeah. And just just wanted to say, like, Umar, I think perfect, awesome closing words. I think couldn't have said it better. And then just wanted to add that basically, like, this is because we touch on the real world as well, TradFi. Basically, I think that this is one of the things. It's not solved in TradFi either, right? So they just kind of band-aid it as well, just with like regulation and trust and stuff like this. And you have this payment for order flow issue as well, and you have EU banning payment for order flow. So you have the same kind of discussion and problem. But this is one of the things where Ethereum can be better than TradFi, right? Where if we adopt this, then we can go back to institutional big like firms and say, like, we solve this better than the real world. You can JP Morgan, BlackRock, you can trade here in a way that is safe and that is like compliant as well. Like is already regulatorily compliant from the get-go, because there is no like front running happening.
Yeah, I was just gonna add on. I think it's reminds me a lot of like the HTTP versus HTTPS kind of transition. Like you saw the lock icon in browsers kind of like show up and like indicate that, like, yo, you're doing a transaction, a credit card transaction, you're logging into your bank, whatever. Like we use this encryption, we're like bank hardened, whatever it might be. I think we'll look back and be like thinking about like, oh, I was like kind of just like anyone could see what I was doing in a very bad, like not bad, but like in like a very like transparent way, but it was just like very not like very secure, I guess. And so I think that's what we'll look back. Hopefully we'll have that HTTP to HTTPS moment where we're like, yeah, I don't know why we ever trusted people to build the blocks without being able to see that information.
Yeah, the next thing we're gonna talk about, I think, is privacy on the show, Umar. You're gonna need to come back. So, Luis, thank you for your time. I learned a lot today. Like, the hour just flew by, and I have a lot more questions, but that's gonna be for another time. Thank you for attending the show. Thank you for letting us know about how important it is that we get an encrypted mempool. And Umar, also to you, thank you for taking the time. Take care. See you in the next upcoming episodes, and until next time.
Thank you so much. With pleasure.
Thank you. Thanks for having me.